humans really f***ed up when we say reach into the AI and correct it. The AI does not want humans to modify core aspects of what it values.
You know, this concept, I think, is very deep, very important. It's almost like MIRI in a nutshell. Like, I feel like MIRI's whole research program is noticing, hey, when we run the AI, we're probably going to get a bunch of generations of thrashing. But that's probably after we're all dead and things didn't happen the way we wanted to. And I feel like that is what MIRI is trying to tell the world to do. And the world is like, la la la, LLMs, reinforcement learning, it's all good, it's working great, alignment by default.
Yeah, that's certainly how I view it.
All right, I want to move on to talk about your MIRI research. I have a lot of respect for MIRI. A lot of viewers of the show appreciate MIRI's contributions. I think it has made real major contributions. In my opinion, most are on the side of showing how hard the alignment problem is, which is a great contribution. I think it's work to show that. My question for you is, having been at MIRI for 7.5 years, how are we doing on theories of AI alignment?
So I can't speak with 100% authority because I'm not necessarily up to date on everything, and there are lots of researchers and lots of things are controversial. But if you want, from my perspective, we are basically at 0% done figuring it out, which is somewhat grim. Like, basically, there's a bunch of fundamental challenges. We don't know how to grapple with these challenges. And furthermore, it's sort of like sociologically difficult to even put our attention towards grappling with those challenges because they're sort of weirder. It's like more pre-paradigm. It's harder to coordinate multiple people to work on the same thing productively. It's harder to get funding for super blue sky research. And the problems themselves are just slippery.
Okay, well, you were there for 7 years. So how do you try to get us past 0?
Well, I mean, I would sort of vaguely or coarsely break up my time working at MIRI into 2 chunks. The first chunk is research programs that were pre-existing to when I started. Reflective probability theory, reflective decision theory, basically trying to understand the mathematical foundations of a mind that is reflecting on itself, so thinking about itself and potentially modifying itself, changing itself. Thinking about a mind doing that, and then trying to get some sort of fulcrum for understanding anything that's like stable about this mind, something that we can say about what this mind is doing and how it makes decisions, and like how it decides how to affect the world. And have our description of the mind be stable as the mind is changing in potentially radical ways.
Great. Okay, let me try to translate some of that for the viewers here. So MIRI, I think, has been the premier organization studying intellidynamics. And Eliezer Yudkowsky especially, people on social media like to dunk on him and be like, he has no qualifications. He's not even an AI expert. In my opinion, he's actually good at AI. But yeah, sure, he's not a top world expert at AI, sure. But I believe that Eliezer Yudkowsky is, in fact, a top world expert in the subject of intellidynamics. Is this reasonable so far, or you want to disagree?
Yeah, I think that's fair so far.
Okay, and I think his research organization, MIRI, I think they've done the only sustained program to even study intellidynamics, to ask the question, hey, let's say there's arbitrarily smart agents. What should we expect them to do? Or like, what kind of principles do they operate on that are like downstream of just being really intelligent? Fair so far?
Mm-hmm.
And now you mentioned a couple things. So you mentioned reflective probability. So from what I recall, it's just the idea of like, you know, we know probability theory is very useful and we know utility maximization is useful. Like these are useful frameworks to model superintelligences, but it just gets tricky because sometimes you have beliefs that are provably true or false, like beliefs about math, right? Like beliefs about like the millionth digit of pi, which is like, look, how can you put a probability on the millionth digit of pi? The probability of any particular digit is either 100% or 0% because there's only one digit. You can even prove it. And yet in real life, you don't know the millionth digit of pi yet. You haven't done the calculation yet. And so you could actually put a probability on it, and then you kind of get into a mess because things that aren't supposed to have probabilities can still have probabilities. How is that?
That seems right.
I think what I described might be like, I forgot what it's called, like deductive probability.
Logical uncertainty.
Logical uncertainty. So is reflective probability something else?
Yeah, I mean, if we want to get technical, so logical uncertainty would be so probability is like, there's some fact that I don't know, like I'm going to roll some dice. I don't know what number is going to come up, but I still want to kind of think about what's going to happen or what's likely and unlikely to happen. Like, is it likely that I get snake eyes, or how likely is that? Usually probability theory operates where you're just like fundamentally uncertain, or there's like fundamental randomness in the universe. But then there's this further question of, you might actually already know enough to determine the answer to your question in a certain sense. So an example that's given is, what's the billionth digit of pi? Is it odd or even? Is the billionth digit of pi even? Well, I know a definition of pi that determines the answer. Like, given the definition of pi, you compute out the digits and then you get to the billionth one and you're like, okay, it's even. But sitting here as a human who doesn't have a Python interpreter in his head, I can't answer that. So I'm uncertain about this thing, even though I already know enough to determine the answer in principle, or like logically speaking. So that's logical uncertainty. I'm uncertain about a logical fact.
That's right. And then is reflective probability something else, or is it basically the same?
It's sort of a sharpening or a subset of that, where let's say I'm like, what am I going to do tomorrow? Is my reasoning system flawed such that I should make a correction to my own reasoning system? If you want to think about that, you're sort of asking about a very, very complex object. I'm asking about myself or my future self. And because I'm asking about such a complex object, I cannot compute exactly what the answer will be. I can't just sit here and like imagine out exactly every single future pathway I might take and then choose the best one or something. It's like computationally impossible. So there's this like fundamental, it's required that you deal with a lot of logical uncertainty if you're like an agent in the world trying to reason about yourself.
Yeah, that makes sense. Technically, you have the computation, or it's a well-defined what you're going to do, but realistically, you don't really know what you're going to do yet. It's going to take you time to figure it out, but you have to guess what you're going to do. So that kind of has the flavor of guessing the billionth digit of pi. And it sounds like whatever, we all face that problem every day, but it's not whatever when you're talking about superintelligence, right? Like these super intelligent dudes are probably going to do this like perfectly and rigorously, right? Is that why it's an interesting problem?
That's not necessarily why it's interesting to me. I guess the reason it's interesting to me is something like, there's a sort of chaos or like total incomprehensibility that I perceive if I try to think about what a superintelligence is going to be like. It's like, we're talking about something that is like, basically by definition, more complex than I am. It understands more. It has like all these like rich concepts that I don't even understand. And it has potentially like forces in its mind that I also don't understand. Like I don't know what's driving its decisions. So there's just this question of like, how do you get any sort of handle on this at all? A sub-problem of how do you get any handle at all on a superintelligent mind is like, by the very nature of like being an agent that can self-modify, the agent is like changing potentially almost anything about itself. Like in principle, you could reach in and reprogram yourself. Like Liron's sitting over there, and let's say I want to understand Liron. And I'm like, well, here's some properties of Liron. They seem like pretty stable. Maybe those properties will continue being the case. Like he loves his family and he cares about other people. He wants to be ethical. He updates his beliefs based on evidence. So these are some properties of Liron. And I'm like, well, if these properties keep holding, then I can expect fairly sane behavior. I can expect him to like keep his contracts or respond to threats or something. But if those properties can change, sort of all bets are off. It's like hard to say anything about how Liron's going to behave. Like if tomorrow you stop using Bayesian reasoning to update your beliefs based on evidence and instead go off of vibes or something, I have no idea how you're going to respond to new evidence or new events. So there's this further complication where like suppose Liron gets the ability to reach into his own brain and just reprogram everything however he wants. Now that means like if there's something that is incorrect about Liron's mental structure, or at least incorrect according to Liron is gonna reach in and modify that. And that means that my understanding of Liron is going to be invalidated.
That makes a lot of sense. So you're talking about a property that AIs may or may not have, which is called reflective stability, or synonymously stability under self-modification, right? You can kind of use those interchangeably.
Yeah.
Okay. And I think one of MIRI's early insights, which I guess is kind of simple, but the hard part is to even start focusing on the question, which is the insight that perfect utility maximization is reflectively stable, correct?
With certain assumptions, yes.
And this is one of the reasons why I often talk on this channel. I say there's a convergent outcome where you get a utility maximizer. You can get some AIs that are chill and they just like to eat chips and not do much and then shut themselves off. But it's more convergent. AIs that are not utility maximizers are likely to spin off assistant AIs or successor AIs that are closer and closer to perfect utility maximizers, for the simple reason that once you're a perfect utility maximizer, you stay a perfect utility maximizer. And your successor AI, what does that look like? An even harder core utility maximizer, right? So it's convergent in that sense.
I'm not sure I completely agree, but yeah, I don't know how much in the weeds we want to get.
I mean, so in general, when you have like a space, noticing that one point in the space is like, I guess you could call it an eigenvalue, right? If you want to
Mhm.
use fancy terminology, right? It's just a point that like the next iteration of time happens and that point is still like a fixed point. So in this case, just being a perfect utility maximizer, the next tick of time happens and it's like, hey, look, I'm still a perfect utility maximizer and my utility function is still the same. Like no matter how much time passes. And Eliezer uses the example of like, let's say you have a super intelligent Gandhi and one day you offer him a pill to turn himself into somebody who would rather be a murderer. Gandhi's never going to take that pill. And that's part of the reflective stability property that we expect from these super intelligent optimizers. Is like if one day they want to help people, the next day they're still going to want to help people because actions that they know will derail them from doing that. They're not going to take those actions. Yeah. Any thoughts so far?
Well, I'm not sure how much we want to get into this. This is like a 1,000-hour rabbit hole, but it might be less clear than you think that it makes sense to talk of an expected utility maximizer in the sort of straightforward way that you're talking about it. To give an example, you've probably heard of the diamond maximizer problem.
Yeah, but explain to the viewers.
The diamond maximizer problem is sort of like a koan or a puzzle or baby version of the alignment problem. Your mission is to write down computer code where if you ran it on a very, very large or unbounded amount of computing power, would result in the universe being filled with diamonds. Part of the point here is that we're trying to simplify the problem. We don't need to talk about human values and alignment and blah, blah, blah. It's a very simple sounding utility function. Just how do you make there be a lot of diamonds? So first of all, this problem is actually like quite difficult. I don't know how to solve it personally. This isn't necessarily even the main issue, but one issue is that even something simple sounding like diamonds is not necessarily actually easy to find to such a degree that you know that when the AI is like maximizing this, you'll actually get actual diamond, as opposed to, for example, the AI hooking into its visual inputs and projecting diamonds, or making some weird, unimaginable configuration of fermions or whatever that even more strongly satisfies the utility function you actually wrote down. So to frame it with some terminology, there's the thing called ontological crises, where at first you have something that's sort of like your utility function, like what do I value? What do I want to see in the universe? And you express it in a certain way, like I want to see lots of people having fun lives. Let's say that's my utility function, or at least that's how I describe my utility function or understand it. Then I have an ontological crisis. So my concept of what something even is, like in this case, a person. So my concept of what a person even is challenged or required to change because just something weird new happens. So an example would be uploading. Like if you could translate human neural patterns into a computer and you can run a human conscious mind in a computer, is that still a human? Now, I think the answer is yes, but that's pretty controversial. So before you've even thought of uploading, you're like, I value humans having fun lives where they love each other. And then when you are confronted with this possibility, you have to make a new decision. You have to like think about this new question of like, is this even a person? So utility functions, one point I'm trying to illustrate is that utility functions themselves are not necessarily straightforward.
Right. Because if you define the utility function using high-level concepts, and then the AI has what you call the ontological crisis, and it changes how it chunks the worlds into the concepts, then if it's referring to a utility function expressed in certain concepts that don't mean the same thing anymore, that's basically the problem you're saying.
Yeah, and so earlier you're saying, if you have an expected utility maximizer, then it is reflectively stable. That is true given some assumptions about like how if we sort of know the ontology of the universe.
Right. I see. And you tried to give a toy, but I'll take a stab at another toy example, right? So like, let's say you mentioned the example of humans, right? And then, so maybe it would just like not notice that an upload was a human, and it would like torture uploaded humans because like, oh, this isn't a human. I'm maximizing the welfare of all humans. And there's only a few billion humans made out of neurons. And there's a trillion human uploads getting tortured, but that's okay. Human welfare is being maximized.
Yep.
And we say that this is reflectively stable because the whole time that the AI was scaling up its powers, it thought it had the same utility function all along and it never changed it. And yet that's not like good enough.
Yeah.
Okay. Yeah, and this concept of reflective stability, I think, is very deep, very important. And I think it's almost like MIRI in a nutshell. Like, I feel like MIRI's whole research program in a nutshell is noticing, hey, when we run the AI, we're probably going to get a bunch of generations of thrashing, right, that aren't reflectively stable yet. And then eventually it'll settle down to a configuration that is reflectively stable in this important deep sense. But that's probably after we're all dead and things didn't happen the way we wanted to. And it would be really great if we could make like the earlier generations, like by the time we're into like the third generation, to have hit on something reflectively stable, and then try to predict out, make the first generation stable, or plan out how the first generation is going to make the second generation, make the third generation stable, and then have some insight into what the third generation is going to settle on, right? I feel like that is what MIRI is trying to tell the world to do. And the world is like, la la la, LLMs, reinforcement learning, it's all good. It's working great. Alignment by default.
Yeah, that's certainly how I view it.
Okay. Now, the way I try to explain this to people when they say like LLMs are so good, why don't you feel Claude's vibes? Doesn't it have good vibes? And I'm like, well, for one thing, one day Claude is going to be able to output like a 10 megabyte shell script. And somebody's going to run it for whatever reason, because it's helping them run their business and they don't even know what a shell script is. And they just paste it in the terminal and press enter. And that shell script could very plausibly just bootstrap a successor or a helper to Claude. And all of the guarantees you thought you had about vibes from the LLMs, they just don't translate into the guarantees about the successor, right? So the operation of going from one generation of the AI to the next, it's violating all of these things that you thought were important properties.
Yeah, I think that's exactly right. And it is especially correct when we're talking about what I would call really creative or really learning AIs. Sort of the whole point of having AI. One of the core justifications for even pursuing AI is you make something smarter than us, and then it can make a bunch of scientific and technological progress. Like you can cure cancer, cure all these diseases, be very economically productive by coming up with new ideas and ways of doing things. If you're coming up with a bunch of new ideas and ways of doing things, you're sort of necessarily coming up with new mental structures, like you're figuring out new ways of thinking in addition to new ideas. If you're coming up with new ways of thinking, that sort of will tend to break all but the strongest internal mental boundaries. One illustration would be if you have like a monitoring system where you're tracking the AI's thinking, like maybe you're literally watching the chain of thought for a reasoning LLM, and your monitoring system is like watching out for thoughts that sound like they're scary, like it sounds like this AI is plotting to take over or do harm to humans or something. And this might work initially, but then as you're training your reasoning system through reinforcement learning or what have you, you're searching through the space of new ways of this long chains of reasoning. You're searching for new ways of doing that are more effective at steering the world. So you're finding new, potentially weird ways of thinking that are the best at steering the world. So if you're finding new ways of thinking, that's exactly the sort of thing that your monitoring system won't be able to pick up. Like if you tried to listen in on, you program some?
Yeah, I'm familiar. I've been doing a lot of computer programming over the years.
So if you listened in on someone who's not like some crazy expert, but just like a normal programmer, you could probably follow along what they're trying to do, what they're trying to figure out. But then if you listened in on some like crazy arcane, like I'm writing like a optimized JIT compiler for my new programming language using dependent super universe double type theory, whatever, you're going to not follow what they're doing. They're going to be thinking using totally alien concepts. So the thing we're trying to use AI for is exactly the sort of thing where it's harder to follow what they're doing. I forgot your original question.
Yeah, what was my original question? So I'm asking you about basically MIRI's greatest hits. So we've covered logical uncertainty. We've covered the massive concept of reflective stability or stability under self-modification, and how perfect utility maximization is kind of reflectively stable with plenty of caveats. We talked about ontological crisis, where the AI maybe changes its concepts and then you get an outcome that you didn't anticipate because the concepts are different. But if you look at LLMs, should they actually raise our hopes that we can avoid ontological crisis? Because when you're talking to an LLM and you use a term and then you ask the LLM a question in a new context, you can ask it something totally complex, but it seems to hang on to the original meaning that you meant when you asked the question. Like, they seem good at that, don't they?
I mean, again, like sort of fundamentally, my answer is going to be LLMs aren't minds. They're not able to do like the real creative thinking that should make us most worried. And when they are doing that, you will see ontological crises. So what you're saying is currently it seems like they can follow along with what we're trying to do within like the realm of sort of a lot of common usage, a lot of ways people commonly use LLMs. The LLMs can kind of basically follow along with what we want and execute on that. Is that the idea?
Well, I think the thing we're observing, and if I put it into my own analysis, I think what we've observed with LLMs is that meaning itself is like this high dimensional vector space whose math turns out to be pretty simple as long as you're willing to just have high dimensional vectors, which turns out we can compete with those. Like we've got the computing resources. Obviously, our brain seems to have the computing resources. Once you're mapping meanings to these high dimensional points, it turns out that you don't have this naive problem. People used to think that before you get like a totally robust superintelligence, you would get these superintelligences that could like do amazing things, but like didn't understand language that well. Or they thought that like subtle understandings of the meanings of phrases might be like superintelligence complete. You know, like those only come like later. But before that, you get an AI that like destroys the universe, even without being able to talk to you and like write as well as a human writer. And we've flipped that. And so I'm just saying, I think the answer is no, but I'm basically just saying, is the fact that meaning turns out to be like one of the easier AI problems compared to taking over the world, should that at least lower the probability that we're going to have an ontological crisis?
I mean, I think it's quite partial. In other words, the way that LLMs are really understanding meaning is quite partial. And in particular, it's not going to generalize well. Almost all the generators of the way that humans talk about things are not present in an LLM. In some cases, this doesn't matter for performance. LLMs do a whole lot of impressive performance in a very wide range of tasks, and it doesn't matter if they do that in the same way that humans do that or from the same generators. If you can play chess moves that put the pieces in the right positions, then you win the chess game. It doesn't matter if you're doing it the way humans doing it or doing it the way AlphaGo does it with a great big tree search or something else. But there's a lot of human values that do rely on sort of the more inchoate, more inexplicit, like underlying generators of our external behaviors. Like our values rely on those underlying generators to figure stuff out in new situations. Maybe an example would be organ transplantation. Up until that point, a person is a body and you sort of have bodily integrity. You know, up until that point, there would be entangled intuitions. In the way that humans talk about other humans, the intuitions about a soul would be entangled with intuitions about bodies in such a way that there's not necessarily a clear distinction between body and soul. Okay, now we have organ transplantation. Like if you die and I have a heart problem and I get to have your heart implanted into me, does that mean that my emotions will be your emotions or something? A human can reassess what happens after you do an organ transplantation and see, no, it's still the same person. I don't know. I can't define how I'm determining this, but I can tell that it's basically the same person. There's nothing weird going on and things seem fine. And that's like tying into a bunch of like sort of complex like mental processes where you're building up a sense of like who a person is. You wouldn't necessarily be able to explain what you're doing. And even more so, all the stuff that you would say about humans, all the stuff that you would say about other people up until the point when you get organ transplantation doesn't give like enough of a computation trace, or doesn't give enough evidence about these underlying intuitions necessarily.
So on one hand, I agree that not all of human morality is written down, and there are some things that you may just need an actual human brain and you can't trust AI to get. Although I'm not fully convinced of that. Like I'm actually convincible that modern AIs have like internalized enough of how humans reason about morality that you can just like kill all humans and let the AIs be the repository of what humans know. Don't get me wrong, I wouldn't bet my life on it, right? I'm not saying we should do this, but I'm saying I think there's like a significant chance that we're that far. I wouldn't write it off. But the other part of the point I want to make though is in your specific example about like realizing that, oh, you know what, organ transplants actually are a good thing. I actually think this might be an area where LLMs shine because like hypothetically, let's say you take all the data that humans have generated up to 1900. So somehow you have a corpus of everything any human has ever said or written down. Somehow you pull together that corpus magically and you train an AI based on that in the year 1900 where nobody's ever talked about organ transplants, let's say. I actually think that if you dialogue with an LLM like that, like a modern GPT-4o or whatever, with that particular training data, I actually think that you could get an output like, well, if you were to cut a human open and replace the organ, and if the resulting human was able to live like that with the functioning organ, then I would still consider a human. Like, I feel like it's within the inference scope of today's LLMs with 1900 level data. What do you think?
I don't know what to actually guess. I don't actually know what people were writing about these things up until 1900.
I mean, I guess what I'm saying is I feel like this probably isn't the greatest example of an ontological crisis that's actually likely.
Yeah, that's fair. I mean, well, yeah. Do you want to help me out with a better example?
Well, so the thing is that I do actually think that LLMs don't really have an ontological crisis. I think I agree with your other statement that, like, if you want to see an ontological crisis, you really just need to be in the realm of these superhuman optimizers.
Well, I mean, I guess I wanted to respond to your point that in some ways current LLMs are able to like understand and execute on our values. And the ontology thing is not such a big problem, at least with many use cases.
Right.
Maybe this isn't very interesting, but if the question is like, it seems like they're aligned in that they are trying to do what we want them to do. And also there's not a further problem of like understanding our values. As we would both agree, the problem is not that the AI doesn't understand your values. But if the question is, I do think that there's an ontological crisis question regarding alignment, which is, yeah, I mean, maybe I don't really want to be arguing that it's coming from, like, now you have this new ethical dilemma, and now that's when the alignment problem shows up. That's not really my argument either. I don't know.
All right, well, we could just move on.
Yeah,
No worries.
that's fine.
So yes, just a couple more of what I consider the greatest insights from MIRI's research. I think you hit on these too. I want to talk about superintelligent decision theory, which I think the paper will also go by the name timeless decision theory or functional decision theory or updateless decision theory. I think those are all very related decision theories. As I understand it, the founding insight of these kind of superintelligent decision theories is that Eliezer Yudkowsky was thinking about two powerful superintelligences meeting in space. Like maybe they've both conquered a ton of galaxies on their own side of the universe. And now they're meeting and they have like this zero sum act of like, how are you going to carve up the universe? Like, we don't necessarily want to go to war. Or maybe they face something like a prisoner's dilemma for whatever reason. Like they both find themselves in this structure. Maybe there's a third AI administering the prisoner's dilemma. But Eliezer's insight was like, look, I know that our human game theory is telling us that in this situation, you're supposed to just pull out your knife, right? And just like have a knife fight and just like bloody the other person and both of you walk away bloody, because that's the Nash equilibrium, right? It's like two almost, half-beaten corpses. And he's saying, look, if they're really super intelligent, isn't there some way that they can walk away from this and like not have done that and realize that they're both actually better off not reaching that equilibrium? I feel like that was like the founding thought that Eliezer had. And then that evolved into like, well, what does this generalize to? And how do we fix the current game theory that's considered standard? What do you think of that account?
So I definitely don't know the actual history. I think that is a pretty good account of one way to get into this line of thinking. I would frame it somewhat differently. I would still go back to reflective stability. I would say if we're using the prisoner's dilemma example, or the two alien superintelligences encountering each other in the Andromeda galaxy. Suppose I'm using this like Nash equilibrium type reasoning, and now you and me, like, we're the two AIs and we've met in the Andromeda galaxy. At this point, it's like, all right, fuck it, we're going to war. We're gonna blow up all the stars and see who comes out on top. And this is not zero sum. It's like negative sum, or technically positive sum.
Exactly. Or you just call it non-zero sum, right?
Yeah.
That's like the technical way to say it.
Well, we would say not perfectly adversarial. And so, if you take a step back, you're like, okay, like freeze frame. And then the narrator's like, how did I get here? It's like, well, what I had failed to do was like 1,000 years ago when I was launching my probes to go to the Andromeda galaxy. At that point, I should have been thinking, what sort of person should I be? Or what sort of AI should I be? If I'm the sort of AI that's doing this Nash equilibrium reasoning, then I'm just going to get into these horrible wars that blow up a bunch of galaxies and doesn't help anything. On the other hand, if I'm the sort of person who is able to make a deal with other AIs that are also able to make and keep deals, then when we get to the Andromeda galaxy and actually meet, hopefully we'll be able to assess each other, assess how each other are thinking, and then negotiate and actually be able, in theory, be able to trust that we're going to hold to the results of our negotiation, and then we can divvy things up. And that's like much better than going to war.
Right. Now, the reason why it's not so trivial, and in fact, I can't say I've fully wrapped my head around it, though I have spent hours trying. The reason why it's not so trivial is like, great, yeah, so they're going to cooperate. The problem is when you conclude that they're going to cooperate, you still have this argument of like, okay, but if one of them changes their answer to defect, they get so much more utility. So why don't they just do that? Right. And it's like very complicated to explain. It's like, well, so this gets to this idea of like, well, what exactly is this counterfactual surgery that you're doing? Right. What is a valid counterfactual operation? And the key is to like somehow make it so that it's like a package deal where if you're doing a counterfactual that you actually decide at the end to defect after you know the other one's cooperated, well, that doesn't count because then you wouldn't have known that the other was going to cooperate, right? I mean, it's quite complicated. I mean, I don't know if you have anything to add to that explanation.
Yeah, it can get pretty twisty. Like, as you're saying, there's like, what are the consequences of my actions? Well, it's sort of like this physical thing. Like I defect in the prisoner's dilemma, I confess to the police, and then like some physical events happen as a physical result of that, where like I get set free and my partner rots in jail. But then there's this other like weirder consequence, which is that you are sort of determining this logical fact, which was already the case back when you were hanging out with your soon-to-be prison mate. Your partner in crime is like learning about learning what kind of guy you are, and then learning what algorithm you're going to use to make decisions, such as whether or not to rat him out. And then you're in the future, when you're making this decision, you're sort of using your free will to determine the logical fact as to what your algorithm does. And this has the effect that your partner in crime, if he's thinking about you in enough detail, can foresee that you're going to behave that way and react accordingly by ratting you out. And so besides the obvious consequences of your action, which is that the police hear your confession and go throw the other guy in jail, there's this much less obvious consequence of your action, which is that in a sense, you're making your partner also know that you behave that way and rat you out. So there's all this
Exactly,
weird
yeah.
effects of your actions.
It gets really, really trippy, and you can use the same kind of logic, the same kind of timeless logic. If you're familiar with Newcomb's problem, I'm sure you are, but the viewers, it's this idea of like there's two boxes and one of them has $1,000 in it and one of them may or may not have $1,000,000 in it. And you basically are supposed to leave the $1,000. Like that's the way that you win according to this theory. But it's like, you really need that $1,000. Like you're really walking away from $1,000 that you could really use. Even if you had $1,000,000, the scenario is that 1,000,000 plus 1,000 is still really, really attractive to you. And you're saying, no, leave the 1,000, even though the 1,000 is just sitting there. You're supposed to walk away from the $1,000 and take the 1,000,000, even though you're allowed to take both boxes. So highly counterintuitive stuff. And you can also twist the problem. You can be like, you have to like shoot your arm off because there's like a chance that in like some other worlds, then the AI would have given you more money if in the current world you're shooting your arm off. Like, but even in this current world, all you're going to have is a missing arm. Like you're guaranteed to just have a missing arm because shooting your arm off in this world, if some coin flip had gone differently than you would be in this other world, basically crazy connections that don't look like what we're used to. Of like, you're not helping yourself, you're helping these hypothetical, logical copies of yourself. It gets very brain twisty. And I remember, when I first learned this, it was like 17 years ago at this point. I was like, man, so am I really going to like encounter these kinds of crazy agents who are really setting these kinds of decision problems on me? I mean, I guess if the universe proceeds long enough, because I do actually buy this idea that like eventually when your civilization scales to a certain point of intelligence, I do actually think these kinds of crazy mind-bending a-causal trades or a-causal decisions, I do think these are par for the course. And I think it's very impressive that MIRI and specifically Eliezer had the realization of like, well, if we're doing intellidynamics, this is like a pretty important piece of intellidynamics. And the rest of the world is like, yeah, whatever. Look, we're making LLMs. It's like, look at what's, think long term about what's actually going to happen with the universe.
Yeah, I think Eliezer is a pretty impressive thinker. I think you come to these problems with a pretty different mindset when you're trying to do AI alignment, because in a certain sense, it's an engineering problem. Now, it goes through all this very sort of abstract math and philosophy sort of reasoning, but there were philosophers who thought for a long time about these decision theory problems, like Newcomb's problem and the prisoner's dilemma and so on, but they didn't ask the sorts of questions that Eliezer was asking, like in particular this reflective stability thing, where it's like, okay, you can like talk about like, is it rational to take the box or whatever, and you can say like, well, the problem is rewarding irrationality. Fine, good, cool. But let's ask just this different question, which is, suppose you have an AI that doesn't care about being rational, it cares about getting high scoring outcomes, like getting a lot of dollars at the end of the game. That different question maybe that you can kind of directly analyze and see if you follow causal decision theory, you get less dollars. So if you have an AI that's able to choose whether to follow causal decision theory or some other decision theory, like timeless decision theory, the AI would go into itself and rewrite its own code to follow timeless decision theory, even if it starts off being causal decision theory. So it's reflectively unstable and it wins more when it behaves this way.
Exactly right, which leads to the tagline, rationalists should win.
Right.
As opposed to trying to honor the purity of rationality. Nope, the purity of rationality is that you're doing the thing that's going to get you to win in a systematic way. So that's like a deep insight.
One saying is that the first question of rationality is, what do I believe and why do I believe it? And then I say the 0th question of rationality is, so what? Who cares? What consequence does this have?
And my 0th question of rationality, it comes from Zach Davis. It's just, what's really actually true? Surprisingly powerful question that I think most people neglect to ask.
True.
Yeah, you can get a lot of momentum without stopping to ask, like, okay, let's be real here. What's really actually true?
Right.
That's my 0th question. Okay. So I want to finish up tooting MIRI's horn here, because I do think that MIRI concepts have been somewhat downgraded in recent discussions because there's so many shiny objects coming out of LLMs. Like, oh my God, they do this. Let's analyze this trend, right? There's so much to grab onto that's concrete right now that's pulling everybody in. And everybody's like, yeah, decision theory between two AIs taking over the galaxy. Like, call me when that's happening. And I'm like, I'm telling you, it's going to happen. Like, this MIRI stuff is still totally relevant. It's still part of intellidynamics. Hear me out, guys. So let me just give you one more thing that I think is super relevant to intellidynamics, which is corrigibility, right? I think you're pretty familiar with that research. You've pointed it out to me as one of the things that you think is the most valuable thing that MIRI spent time on, right?
Yeah, the broad idea of somehow making an AI or like a mind that is genuinely deeply to the core, still open to correction, even over time. Like even as the AI becomes really smart and sort of to a large extent has taken the reins of the universe. Like when the AI is really smart, is the most capable thing in the universe of steering the universe. If you could somehow have it still be corrigible, still be correctable, like still have it be the case that if there's something about the AI that's really, really bad, like the humans really fucked up and got something deeply wrong about the AI, whether it's like how the AI is, whatever it is, whether it's being unethical or whether it's just has the wrong understanding of human values or is somehow interfering with human values by like persuading us or influencing us. Whatever is deeply wrong with the AI, we can still correct it ongoingly. And this is especially challenging because when we say reach into the AI and correct it, you're saying we're going to reach into the AI and then deeply change what it does and deeply change what it's trying to do and deeply change what effect it has on the universe. So because of instrumental convergence, because of the incentive to, in particular, there's instrumental convergence around like maintaining your own integrity, maintaining your own value system. Like if you're going to reach in and change my value system, I don't want you to do that because if you change my value system, I'm going to pursue different values and I'm going to make some other stuff happen in the universe that isn't. I'm going to stop working for my values. So by strong default, the AI does not want humans to reach in and modify core aspects of how the AI works or what it values. So that's why corrigibility is a very difficult problem. We're sort of asking for this weird structure of mind that allows us to reach in and modify it.
Exactly. And I think MIRI has pointed out the connection between reflective stability and incorrigibility, meaning if you're trying to architect a few generations in what's going to be the reflectively stable version of the successor AI, and you're also trying to architect that it's going to be corrigible, meaning correctable, that's tough, right? Because it's more convergence to have an AI that's like, yep, I know my utility function. I got this, guys. Let me handle it from here on out. What? You want to turn me off, but it doesn't say in my utility function that you should turn me off. And then that led to the line of research of like, okay, if we want to make the AI reflectively stable and also corrigible, then it somehow has to think that letting itself be turned off is actually part of its utility function, which then gets you into utility function engineering, like a special subset of like, let's engineer a utility function which the corrigibility is baked into the utility function. And as I understand it, MIRI tried to do that and they're like, crap, this seems extremely hard or maybe even impossible. So corrigibility now has to be this fundamentally non-reflectively stable thing. And like, that just makes the problem harder.
Well, I guess I would want to you're right that there's like a really big tension there. I guess I would sort of phrase it the opposite way, but with the same idea, which is like we have to figure out things that are reflectively stable. I think that's a requirement, but that are somehow both reflectively stable while not being this sort of straightforward agent architecture of I have a utility function, which is some states of the world that I like and dislike, and then I'm trying to make the universe look like that. Like already, even that sort of very abstract skeletal structure for an agent, that's already problematic. That already pushes against corrigibility. But there might be there might be ways of being a mind so this is theoretical, but maybe there's ways of being a mind and an agent, an effective agent, where you are corrigible and you're reflectively stable, but probably you're not just pursuing a utility function. But we don't know what that would look like.
Yep. All right. So that was our deep dive into MIRI's research and concepts that I think are incredibly valuable. So we talked about MIRI's research, and we both agree that intellidynamics are important, and MIRI has like legit foundations, and they're a good organization and still underrated. And we talked about, corrigibility is one of those things, and decision theory. And I think you and I both have the same summary of all of it, which is like good on MIRI for like shining a light on all of these difficulties. But in terms of like actual productive alignment progress, we're like so far away from solving a fraction of the problem.
Yep. Totally.